Okay, so on this paper, we're kind of going to be talking through everything we've discussed so far in this chapter, everything that we've kind of put together. So we're talking about proportional. We're talking about rate of change. Do you remember proportional yesterday? We said if it's proportional, it's also a... What? Direct variation. Very good. What did we say? Rate of change. What was the other name for rate of change the other day? What was the name? Nope. That's another way of talking about it, but what's the other name for it? It starts with an S. Slope. Very good. Okay. So we're kind of taking all of the ideas of proportional and direct variation and rate of change and slope and putting it all together and saying how everything relates to each other, what it all means, okay? So this is going to be a really helpful paper as you maybe fill out your review next week or things like that. Notice it's not on colored paper, so that means this is not something you're going to be able to use on your test. But this is something that can help you as you're trying to prepare for it and knowing what to do when and things like that, okay? So raise your hand when we get to blanks if you think you know how to fill it in. So when it's proportional, on a graph, proportional means there is a straight line that goes through the origin. And next to origin, we have some space, so put 0, 0, so you know that's where the origin is. To determine if a table is proportional, we take y divided by x to see if all of the blank are blank. Every time we do the table, we go y divided by x, y divided by x, y divided by x, y divided by x. And we want to know if all of those are equal. So all of those what? What did we call those? Rates. Very good. All of the rates are equal. If they are all equal, when we do y divided by x, y divided by x, y divided by x, that means that the table is proportional. Yesterday we said a direct variation is also called, or a direct variation means it is proportional. Very good, thank you. A relationship is a direct variation if it is proportional. And we can write the relationship then in the form y equals kx. So this is the direct variation equation we were using yesterday. Okay? Here, k, or our constant of proportionality, is represented by whatever the value was for y divided by x. Okay, k is equal to whatever is y divided by x. That constant value that we kept getting here, that equal value on every single one, that is k. So like on our blue paper, if you remember, the one that was proportional, we divided them out each time, and it came out to be 3. So in that case, our k value was 3. When it says something, these two words are the ones that I asked you to highlight yesterday as we went through. Varies directly. So when it says something varies directly, that means we know that it is proportional. And if we know it's proportional, we know all of the y divided by x will be... Raise your hand. I should see more than one hand. That's what I'm waiting on. All of you, go ahead. Equal. Okay? So if it's a direct variation, we know it's proportional. We know that every y divided by x will be equal. That's our k value. Our k value can then be written into the equation y equals kx. We can use that equation then to figure out, well, what if x was this? Then what would y be? What if y is this? What would x be? Because we know the relationship between those two variables then. We know what our constant multiplier is. Okay? The other idea is rate of change. On a graph, we call a constant rate of change the, what did we say another name for constant rate of change is? Go ahead, Jackson. Slope. Very good. On a graph, we tend to call it slope. And we find it by looking at rise over run. If there is a constant rate of change, the graph will be a what? What will it look like if there is a constant rate of change? Evelyn? Straight line. And you can add in here at the end linear. Straight line, we tend to call that linear. Okay, it will be linear if there is a constant rate of change. And guys, we talked about this. If you look up at the board still from this white book, remember we have our blue line here, and I did 3 different rise over runs. I did 3 different slope triangles. I have one that goes up 10, right 15. I have one that goes up 4, right 6. I have one that has a rise of 2 and a run of 3. Anytime we did that, we simplified them, and they all were equal. They all had the same slope of 2/3. If they all have the same rate of change, we say it's a constant rate of change. Since it's constant throughout, it's going to be a straight line, because we went up 2, right 3, 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 up 2, right 3. Since we're moving the same way from one point to the next on the line, it will be a straight line. If we're moving at different rates, that means it's not going to be a straight line. So the one right below looks like this. We went up 2, right 3, up 2, right 3, then up 1, right 4. So that is not a straight line because we changed how it was moving. One point to the next was moving different ways. Okay? It says to determine if a table has a constant rate of change, we take the change in y over change in x to see if all the what are whats. Are equal. Very good. Okay, see if all the rates are equal. So really, between rate of change and proportional, we're trying to do the same thing in the table. We're seeing if the rates are equal. The only difference is here in the table, we do y divided by x. Those are the numbers inside the table. And here we're doing the change in y over change in x. Remember in our table, if I do a quick table, this is how they are changing on the outside. It is not the numbers in the table. It's like, okay, this is +2 and this was +1. That's what we mean by change in y over change in x. Okay? So we're both trying to see, are the rates equal? It's just a matter of how we're getting those numbers in our rates. Okay? It is also important to know that slope is the same thing as m, is the same thing as rise over run, is the same thing as change in y over change in x, is the same thing as y2 minus y1 over x2 minus x1. Those are all the same thing. It's just a matter of we tend to talk about each one when we're starting with a different type of problem. We tend to talk about m if it's an equation. That's why we haven't discussed it much yet. We haven't talked about what an equation looks like if it's not a direct variation. The next lesson talks about what it looks like if there's just a constant rate of change but not going through the origin. So that equation is going to use m. We tend to talk about rise over run when we have a graph in our problem. We tend to talk about change in y over change in x when we're looking at a table to begin with. And we tend to do y2 minus y1 over x2 minus x1 when we are given 2 points. So it doesn't mean that we can't use change in y over change in x for 2 points. It just means this is normally the way we think it through. Okay, because it means the same thing, it's just a little bit more specific for that type of problem. Okay? The last part here says, since being proportional means a straight line through the origin, and constant rate of change means having a straight line, if something is proportional, that means it must have a what? It must have a what? Nope. If something is proportional, it must have a, Jackson? Yeah. If we know it's a straight line and through the origin, it has to have a straight line. Straight line, linear, means there's a constant rate of change. However, it doesn't work the other way around. Just because we know there is a straight line doesn't mean it's also going to be a straight line through the origin. And if you look up at the white book that has positive and negative lines, you can see this. This green one is a straight line and it goes to the origin. So that is a proportional line. Since that's proportional relationship, we know it's also a constant rate of change. It has to be straight. Okay? But this purple line has a constant rate of change. It's a straight line, but that doesn't automatically make it proportional, which it's not. It doesn't go through the origin. Okay? The last part says, if it is proportional, y divided by x is equal to change in y over change in x. And that was on our blue paper to begin with. If you look back at that at some point, you will see our first example. When we did y divided by x, it was 3 each time. Then when we did change in y over change in x, it was 3 each time. The reason that worked was because it's proportional. That only happens if it's proportional. If it's not proportional, they will not be equal. The other way you could say this is y divided by x is what variable? Y divided by x is what variable? K. And change in y over change in x is what variable? M. So if it's proportional, your k value and your m value will be the same number. If it's not proportional, they will not be the same number. Is that okay? All right, we're going to look at some examples from 3-3 as well. Okay, so let's see. This should help a little bit with the homework, and you'll have some homework time in the next class, okay? So it says, how do you know if an equation is a direct variation equation? So how do you know, if you're looking at an equation, that it's a direct variation? What will it have to look like? Not what will the graph look like, or the table, does the equation look like? If you're not sure, look at the paper right in front of you. If it's a direct variation, what does the equation, Rain, have to look like? It has to look like y equals kx. Can somebody give me an example of an equation that is in direct variation form? Y equals 5x. Could 5 have been a negative number? Could it have been a fraction? Could it have been a decimal? Yeah, as long as it's y equals kx, it would work. Could somebody give me an example of one that is not a direct variation? Very good. Remember, if we had a plus something at the end, a plus a constant, a minus a constant, that makes it not a direct variation. Very good. Nice job. Okay, the next one, we have 2 graphs on the homework. Okay, it says the number of miles varies directly with the number of hours. How many miles will the family travel per hour? First of all, what should I be highlighting here? What would I highlight in this one? Very good. Varies directly. Okay? Varies directly tells me this is a direct variation. If it's a direct variation, it means it is proportional. If it's proportional, we do what over what? Y over x. Very good. So if I want to do y over x, I understand that we have the graph there, so we can tell what our y and what our x is. But how would I tell if we didn't have the graph and it was just the words there? It was just the description there. How would I tell which one is y and which one is x? Go back to that sentence with the highlighting. How would I be able to tell, Hallie? Very good. So what is my y? Miles. Very good. So what is my x then? Hours. Very good. Okay. And again, because it says varies directly, you guys told me that means it's a direct variation. That means it's proportional. That means every y divided by x will be the same or equal, right? Will be equal. Okay? We can't use the word proportional to explain what proportional means. A lot of you keep saying it will be proportional. But I'm kind of asking, proportional means the y divided by x equals what? Okay? They're all going to equal the same thing. All right? So when you're looking at this, I don't have to test out every single one of these points because the words varies directly here tells me they're all going to be equal to each other. So you just pick one of them. In this point, what is my y? In this point, what is my x? Can you divide that out for me? Anybody? So what does that mean here? First of all, that's my k value, but what does this mean? How many miles will the family travel per hour? Very good. 60 miles per hour. Perfect. Okay, is that all right? All right, the next one we want to look at. I forgot to type this part in ahead of time, but normally it would say solve the direct variation word problem. So you know this is a direct variation. You know it's proportional. You know we're doing y divided by x. So what y and x am I going to use together here? James? Very good. -5 and 2. Yes, I know we have another x down here, but that goes at the end. These are the two that go together because they have that if and when statement. If x is -5, when y is 2. So those have to go in the same part. Okay? Can that simplify? No, but you can change it to a decimal if you want. A lot of people have preferred turning it to a decimal. What would that be as a decimal? Anyone? -2.5. So remember, this is my k value. K is equal to y divided by x. So I know k is -5 over 2, or -2.5. So what is my equation? What is my equation for this direct variation? Very good. This would be my equation then. So you have to write your equation. And guys, I want you to please listen to this. One of the big mistakes that I see on the quiz, on the test, is that people write the next part with the work as their equation. The equation has to have the y and the x in it. Then we do the work afterwards. So I'm plugging in what number? For what letter? So I'm going to write that right below x, and I'm going to fill in the rest. Since they are on the same side, we are just multiplying those two together to find my y value. So go ahead and do that. When x is 11, what is y going to be equal to? When x is 11, what would y be equal to? Raylan? -27.5. Very good. Okay. We will finish the last part in lab. Go ahead and pack up. All right, on this problem. So this problem says Jed spends $18 playing 9 games at the county fair. The amount of money spent on games at the county fair varies directly to to the number of games played at the fair. If Jed only has $22 to spend on games at the fair, what is the maximum number of games he can play? So first of all, what would I have highlighted?
The various amount, or varies directly.
Very good, varies directly. That tells me that this is a direct variation. That automatically means this is proportional. If it's proportional, we do what over what?
Y over X.
Very good, y over x. So I know I'm doing y over x, but I don't know yet what y stands for and what x stands for. Who can tell me what y stands for? Who can tell me? Evelyn.
The cost of
I'm sorry?
the cost of the game.
So the amount of,
Money.
so not really thinking it doesn't say cost, but you're right. It's talking about money and the cost. So that's my y, okay? And my x then, Breeza, is number of games. Very good. That's my x. So I like to put money over games because that helps when I need to know, okay, what's my y, what's my x? I know what labels I should be looking for. So what should I put? What numbers should I be using for my money, Colin? 18, right? Up here it said $18 with 9 games. So $18. And how many would I put for my games, Braxton? 9. And if I simplify that, what do I get? 18 divided by 9 is 2. So 2 is my k value. So if that's my k value, what would my equation look like? What would my equation be? Go ahead. Y equals 2x. Very good. This is my direct variation equation. It's in direct variation form because it's in y equals kx form. Very good. The last part now is it wants us to know, what about if I have $22? How many games can I play? Well, where would I plug in 22 to this equation? Would I plug it in for the x, Parker, or the y? Why are you saying the y?
Because it's money and there's other games.
Yeah, very good. Right here, if you look, that's money. Money is my y value. So I'm going to plug 22 in here. And then I write the rest of the equation the same way. So from here, I solve. Since they're not on the same side, I actually have to do work to solve. What would I have to do to solve?
Divide it on both sides by 2.
Good. Divide both sides by 2. And I would end up with x would be what? 11 what, though? It's a story problem. 11 games. Very good.
Yeah, 3 right.
Okay. Are there any questions on that one? Okay.